Hello, guys. Welcome back to Maths on African Motives. We are still on our revisions for March test exams that we are working on. And this is a Northern Cape exam that we are going to look into. That was our control test for March 2025. All right. So we had a 2-hour paper out of 100. All right. So we want to see how we are going to attempt these typical questions. So for you to download this question paper, just check the description of the video or the comment section. You are going to check, you're going to see the link that you can use to download this question paper. So that is it, guys. And make sure you read all the instructions and information, that is, answer all the questions, everything, guys, that you're given here. Make sure that you go through it. If necessary, round answers to 2 decimal places. All right, that is a major instruction for you to consider on that part. And diagrams are not necessarily drawn to scale. Diagrams are not to scale, guys. All right, so do not measure diagrams from what you're given. All right, you must use a mathematical concept to answer those questions. So question 1, in this case, they gave us part of our algebra, working with algebraic expressions, equations, working with inequalities at the same time. That was our question number 1, which is important, right? In other provinces, they do not give this part of question number 1. They will just ask according to the ATP, according to what you are working with in term 1. But in this case, they are giving us also these basics, remember, from your grade 11 mathematics. So we are given 1.11. All this is to solve for x. And 1.11, we have got 2 brackets there, 3x minus 6 into x plus 5. This is what you're given, and that's equal to 0. Remember the zero product, guys, the product of 2 terms, 2 brackets. For us to obtain a 0 there, it means one of these must be equal to what? To 0. So it's either this must be equal to 0, this must be equal to 0. So that is the case. 3x minus 6 is supposed to give us a 0, or the bracket of x plus 5 is supposed to give us a 0. So that's, we can solve for x. So 6 there is going to give us what? A positive. Then divide by what? By 3. That's our x is 2. All right, so this is it. Take the 5 to the other side. That was going to give us a negative. All right, so these are the 2 possible values of x. So that was it, guys. Without wasting our time, 1.12, a quadratic equation, correct to 2 decimal places. The moment you're given this, you know that you must use your quadratic formula, or you can work with completing of the square method. All right, completing of the square, or what? Quadratic formula. So I'm just going to use the quadratic formula, guys. 1.12. Remember, all right, let's save our equation. 7x squared plus 4x minus 9, that's equal to 0. Remember our quadratic equation in the form ax squared plus bx plus c is equal to 0. This is exactly the format that we must have. So that is it. So to use our formula, x is equal to what? Minus b plus or minus the square root of b squared minus 4ac, everything over what? Over 2a. So our a being the coefficient of what? X squared. So in our case, our a is 7. B is the coefficient of x, which is what? A positive 4. And c is the constant, which is what? Negative 9. So that was it. You substitute into your formula all this. So that's minus our b, that is what? 4, plus or minus the square root of b squared, which is what? 4 squared, minus 4. Our a is what? Is 7, and our c is what? A negative 9. All right, so just put those ones inside the brackets over 2 times a, which is 2 times 7. So that was it. We can solve this direct. Just use your calculator, or we can simplify what is under the square root, these terms only under the square root, all right, to see what we are going to have. Sometimes they give a mark on this stage, so just simplify it, all right, this part under the square root, all right. So from your calculator, we need, in this case, all right, this part under the square root, that is 4 squared minus 4 into what? Minus, so that's a positive 7, then into a negative what? A negative 9. So that was going to give us 268. So that's the square root here of what? 268, what we obtained. All right, so we're going to have the square root of 268, everything over 2 times 7, which is 14. So we can now obtain the exact values. Our x is what? All right, so starting with the positive, that's negative 4 plus the square root of what? 268 over 14. And that was going to give us 0.88 to what? To 2 decimal places. So that's 0.88, or our x is equal to what? Having a negative, this time we're going to put a negative here. All right, so that was going to give us what? Negative 1.4. The 5 here is going to change this 5 into a 6. So that's negative 1.46 to 2 decimal places. Negative 1.46. So that is it. Our answers to what? To 2 decimal places as we are given the instruction. So just like that, guys, your quadratic equations from quadratic formula. All right, moving on to another part of the question, which is 1.13. We are given to solve this, and that is an inequality that we are given there. That's an inequality. 3 minus x into the bracket of x plus 7. This is less than what? Less than 0. Solve for x. Remember, when you are working with the inequalities, guys, you are given a quadratic, a 4x, whatever that you are given here. All right. Let's just say negative 5. I'm just giving you an example of what you must expect for a quadratic inequality, which is less than 0, like that. Then you factorize whatever that you're going to have so that you obtain what? The critical values, isn't it? So in our case, guys, already the factorization was done for us. So there is no need for you now to start to expand, because expanding, you're coming back here, then you what? You do factorize again. Already they factorize this for us. So meaning to say, just find your critical values first. Each bracket you equate to 0.3 minus x must be equal to 0 to have the critical value. So minus x is equal to what? 3 to the other side. That's a negative 3. Divide by negative 1. So our x was going to be what? A positive 3. All right. So as of our critical values, x is equal to 3. Or taking the x plus 7, equating it to 0, this one, we are going to obtain what? A negative 7 there. If you take this to the other side, the sign changes. So therefore, our x was going to be a negative 7 as part of your critical values. With the critical values, you can have the inequality by knowing the shape of the quadratic graph that you are given, or the parabola that we are given, because we do understand, guys, if we expand these brackets, we're going to have something like ax squared plus bx plus c, which is a quadratic. So we're not worried about expanding everything, just focus which part gives us the shape of the graph when you're given something like this. It is the a, the coefficient of what? Of x squared. So x squared is obtained when you multiply these two terms. That is only the only part where you're going to have what? X squared. So just focus on that part. minus x and a positive x was going to give us what? Minus x squared. This tells us the shape negative when a is less than 0, when a is a negative value less than 0. What happens on the shape? We do understand that the shape is going to be this way. For us to have what? Negative. If it is a positive, it's going to be like this. So in our case, we are going to have something that is what? Concave down for a negative. All right, so that is the condition now for us to obtain the exact solution. Something that is what? Concave down with the two different solutions, a negative on the left side, then the positive on the right side. So these are the x values of your given function. So where is it that this function f of x is less than 0? Where is it that our function is less than 0? It is what? Below the x-axis, because in the x-axis, that is where y is a 0. So where is it our f of x? It is below the x-axis, below. So you're talking about the region below this side and this side. Remember, guys, I talked about this on your introduction. Check grade 11 mathematics. Yeah, that is, check the playlist on inequalities. Okay, so when it is like this, this will be the region where x is what? Is less than negative 7. All right, there is no equal to here, so do not put that equal to because it's not there on the question. Or x can be values on this side of x from 3 going this side. These values, they are what? They are greater than 3. So this is the condition of our x, where x can be a real number. So you see, guys, just direct. It was a direct question because already they factorized for us. So you just have to find critical values, then you have the exact solutions. All right, let's consider another part, 1.14. So for x, again, we are back to those equations under our sets. Remember the sets in grade 11 mathematics, you dealt with the sets. So actually, question number 1, do grade 11 mathematics as it is. As it is. All right? As it is. So our sets, we are given that 3 square root of what? X plus 3 minus 5, that is equal to x. So remember that what we need is to isolate or to make the square root the subject of the formula. But in our case, guys, we can see that there is a 3 which is multiplying the square root. So this one, when it is a product, you can take it as a single term. So where you want to make the square root, guys, the subject, instead just determine or just work out this 3 square root of x plus 3. It's a single term when it is like this. So we can say 3 square root of x plus 3. The minus 5 is not part of this. It is subtracted from this single term. We are going to subtract 5. So let's get rid of it to the other side of the equation. So we can simply add a 5, add a 5. So that was it. This cancels. So therefore, we've got what? X plus 5. So if we have the left-hand side being equal to the right-hand side in this end, the left-hand side is a single term. Like I said, with these 3 as a product, it's a single term. We can get rid of the square root by what? Squaring both sides. So we have to square both sides of the equation. Squaring this, it is going to give us 3 to the exponent of 2. So it's going to be 3 to the exponent of 2 times the square root of x plus 3 to the exponent of what? To everything raised to the exponent of 2. So 3 to the exponent of 2, that is 9. The square root, when raised to the exponent of 2, remember, it neutralizes. So you're left with what? X plus 3, which is an expression. So 9 has to multiply that expression, open a bracket for that. Okay, so this is equal to what? The left-hand side, our right-hand side, guys, is just a normal expansion. Remember the a plus b concept. A plus b squared is a squared plus 2ab plus b squared. So that is x squared, the first term, plus 2 times A times B, 2 times our A is X, our B is what? Is 5. So that was going to give us what? 10X plus B squared, which is the last term squared. So 5 squared is what? 25. You have expanded using a direct expansion for a bracket being squared. Or you can open two brackets, expand as usual. All right. The left-hand side we can simplify as 9 is to affect every term inside this bracket. You must distribute by what? By 9. Each and every term is what? Multiplied. So that was going to give us 9 times x, which is 9x. 9 times 3, which is what? Positive 27. So that's equal to x squared plus 10x plus 25. Solving for x, as we have got a quadratic equation, we must know the format of a quadratic equation. That's ax squared plus bx plus c equal to 0. Are we having that? No, because this is not equal to 0 or this side is not equal to 0. So it's either we are going to move these terms to the other side or we are going to move these ones to the other side of the equation. So guys, as you can see, it is easier for us to just take these ones to the other side where x squared, where this is already what? A positive. Anyway, guys, the way that you want, it is still one and the same. So taking the 9x to the other side and the 27 to the other side, it means we are going to remain with a 0 here, which is equal to x squared. 10x and the 9x, these are considered as what? Like terms. 10x, 9x. So as you take the 9x to the other side, it will be what? A negative. Remember, it's just like subtracting that. So that was going to give us 10 minus 9, which is what? Which is 1x. So that's positive x. The same thing with the positive 27. To get rid, it was going to be minus 27, minus 27. So that's 25 minus 27, which is what? Minus 2. So this is what we have. Remember, if A is equal to B, it simply means B is also equal to A. So if 0 is equal to this, therefore it means this is also equal to 0. It simply means x squared plus x minus 2 is equal to 0. There is no effect from this part. It's just one and the same. All right, so this is it. From here, guys, you had to clear out the square root so that you form a quadratic equation that you are used to, just like all these quadratic equations that you've been solving. So you can use your quadratic formula. You can go back to this concept of two brackets done by what? Factorization. So let's test our factorization. Right, before we look into the quadratic formula. Here's the coefficient of x squared 1, negative 2. Do we have factors of negative 2, which adds up to positive 1, 2 and negative 1, negative 2 and 1. So if you add these, we are going to obtain a positive 1. So factorization is possible. All right, factorization is possible. So we can factorize this. So x here, x here. Remember the minus 2 concept, the product that will give us a sum. When we add, we get positive 1. That's 2 and what? Negative 1 plus 2 minus 1. From the 0 concept, each bracket as we have here must be equated to 0. So that's x plus 2 equal to 0. X will be what? X will be a minus 2. All right, x is going to be a negative what? A negative 2. Or our x is going to be negative 1 to the other side. That was going to be a positive. So those are the two possible values according to the quadratic equation that we solved here. But we must test these values to see if they are exact values for the given question now that we are given before, for the given question. These are for this quadratic equation that we solved here. They satisfy that. But do they satisfy the original question that we're given here? We must test that, right? So taking into consideration the first or the original equation that we're given, it was 3 square root of x plus what? Plus 3 minus 5, and that's equal to x. So we want to test it to say, if our x is equal to minus 2, it means the left-hand side must be equal to the what? To the right-hand side, of which the right-hand side, x, is what? It's minus 2. So let's simplify the left-hand side and see if we are going to obtain the same answer if our x here is what? Is minus 2. All right, so you can simply use our calculator here. 3 square root of minus 2 plus what? Plus 3. Then after this, we must subtract a what? A 5. So that was going to give us minus 2. So as you can see, guys, minus 2 is equal to minus 2. So x can be equal to what? Minus 2. What about when x is equal to 1? When x is equal to 1, you do the same. You put a 1. So already here it's what? It's a 1. X is what? Is 1. So we are working with the left-hand side. Just put a 1 in place of that minus 2 here. We're going to put a 1. So this is it. As you can see, our answer is 1. So 1 is equal to 1. So meaning to say also 1 is a solution. So both solutions in this case are what? Valid. Both solutions are what? Are valid, or they are correct. Both, in this case, we are going to mark both solutions, all right? So this is what you are going to need in your revisions. Do as many questions, like I always say, guys, do as many questions. Prepare for the exams with proper information. You must have proper information. All right, without wasting your time, guys, let's consider 1.2, part of our simultaneous equations. Solve for x and y. Given these two equations, all right? So if we check the first equation, that is y is equal to 3x plus 2. All right, it is already in simplest form, like y is already the subject of the formula, right? That's our equation 1. From equation 2, is it possible that we can make y the subject? Because here, y is the subject. Let us make y the subject because it's 1 over y here. So it is easier for us to make y the subject. If 1 over y is equal to 2, it means y there, to obtain y, you interchange. So it will be y is equal to, here is same as over 1. So if you interchange, it's going to give us 1 over 2. 1 over y is equal to 1 over x. So the moment we interchange, it means y is equal to what? Y is equal to x. So that's what I'm trying to say. It is easier for us to make y the subject from the reciprocal concept. So let's make y the subject from this equation. 1 over y as it is must be equal to what? Taking 3 over x to the other side of the equation is going to be a negative there. So it's negative 4, negative 3 over x, all right? So we cannot make y the subject, like to just say 1 over, then here it's not a single fraction. Let's have a single fraction so that we can use the concept of what? The inverse of a fraction, to say if it is a over b, its inverse will be b over a. So it's easier when it is what? A fraction. All right, so combine. This was going to give us 1 over y is equal to what? Adding this, we're going to need the LCD, which is x, between 1 and x. That's x. X divided by 1, that's x times negative 4. So that's negative 4x. X divided by x, that was going to give us 1. 1 times minus 3, that's what? A negative 3. So as we can see, guys, we have a single fraction. So that's y is equal to what? Interchanging, y is equal to, you also interchange here. So it's going to be x over what? Minus 4x minus 3. Okay, so this is what you were going to have. As these two equations are the same, equation 1, y is equal to something. From our equation 2, also y is equal to something. So equate that something, all right, from the two equations. All right. Y is equal to 3x plus 2. Another one, y is equal to this. So therefore, equating the two equations, we are going to have 3x plus 2 from first equation equated to the second equation where y is equal to what? X over minus 4x minus 3. So you can simply equate that. Solve for x because those, for the two equations, you'll be having x as what? As the unknown. So you can solve for x. So this is x over what? Minus 4x minus 3. That's another way that you could have just solved this equation, all right? Or simplifying this, guys, we can cross multiply, of which it's fine, but as we can see here, negative is common, guys. We can see that there's a negative, so we can take that negative out. So it's going to be like this, x over negative 4x plus 3. The moment we factor out the negative, so the negative can be written on top before you cross multiply. So it's going to be negative x over what? 4x plus 3. From here, this is what you're going to get. All right, so it'll be easier, guys, working with positive, but not to say even with that negative, you're not going to get answers. You're going to get answers, but we can avoid that. All right, so let us cross multiply, meaning to say these two brackets, we will multiply each other, 3x plus 2, 4x plus what? Plus 3. That's equal to 1 times minus x, which is minus x. Expanding the two brackets, remember your FOIL method. So 3x is going to multiply to 4x, which is what? 12x squared. 3x is going to multiply 3, which is positive 9x. We are done with 3x. Moving on to positive 2, it multiplies 4. That's going to be positive 8x. And 2 and 3, that's going to be positive 6, which is equal to minus x. The left-hand side, we have got like terms. So collect those like terms, 8x and 9x. So that was going to give us 12x squared plus 17x plus 17x plus 6. All right, that's equal to minus x. We have a quadratic equation that has the power being 2. So let's take this x to the other side so that we remain with what? As 0, just like before. So it was going to be plus x to get rid of this, plus x here. Those are like terms. So meaning to say we're going to have 12x squared, 17 plus x, 17x plus x, that's going to be 18x. All right, plus 6, and that's equal to 0 there. Looking into our equation, yes, we can see that we can just use our quadratic formula, but we can see that 6 is the highest common factor. 6, 6, 6. So you can simply divide by what? By 6. So that's going to be 2x squared plus this is going to be 3x plus what? Plus 1. All right, so that's equal to 0. With this equation, you can use your quadratic formula or you can use factorization. Remember the factorization, guys, I taught you guys in your grade. In fact, I did this one. Check the playlist on what? On algebra, where I referred to the cheat method on the factorization of this type of quadratic expressions. So we can use the cheat method. 2 multiplies the 1 there. So take that, multiplies 1. So it's going to be x squared plus 3x plus what? 1 times 2, which is 2. Then we can factorize as usual since the coefficient of x squared is now a 1. So we're going to have 2 brackets, x here. Then considering the factors of 2, which gives us what? A 3. That's 2 and what? And 1. 2 times 1, that's 2. But if we add, we are going to get a 3. So that was 2 and what? 2 and 1. But this is not our answer. This was an answer from this one, which is not the original question because we do not have the 2. We removed that 2. So we must get back, this 2 back to our equation. Where there is x, we put back the 2. Where there is x, we put back the 2 that we removed before. So that's the cheat method. All right, cheat, 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 like that. Okay, so that is it. So we are going to put back the 2 that we removed before, then factorize where possible. Factorize where possible in these two brackets. The first bracket, 2 is common, so you can factor it out. That is going to give us what? 2x and 2, that's x. 2 and 2, that's 1, into 2x plus 1. The second bracket, nothing is common. The one that we factored out is useless. So meaning to say this is our answer from what? Factorization. We're going to have these two brackets. That is the bracket of x plus 1 and 2x plus 1. So this is it. Here, guys, obtaining these two brackets is in your hands. Use whatever method that you understand, all right? Or if this factorization is not part of you, use the quadratic formula. Still, you're going to get your full marks. All right, so from here, we are saying these two brackets, they are equal to 0. So therefore, x is equal to what? The 1 to the other side is going to give us a negative 1, or our x is going to be what? 1 to the other side was going to be negative, but we have to divide by the 2. It's like 2x is equal to this. Divide by what? By 2. So that was going to give us a negative half. So that is it. We have got the values of x. From that, we have got what? The values of x, which we are going to use to find the values of y by substituting in any one of these two equations. Remember, y is the subject here. The second one, y is also the subject. So you choose any one of your choice. So in this case, guys, I'm just going to use that one. That is easier. Y is equal to what? 3x plus 2. Substituting these values into equation 1, where y is equal to 3x plus 2, you're going to obtain the y values. So that's for x is 1, 3 into negative 1 in place of x, plus what? Plus 2. So that was going to give us negative 1. For the value of y in that case, y is equal to, when x is minus half, so that's 3 into x minus 1 over 2 plus what? Plus 2. So we substituted in this case the corresponding value of x when x is minus 1, here when x is what? Minus half. And thus we are going to obtain the y value corresponding to this one. That was 1 over 2. All right, so just put into your calculator 3, open bracket, minus 1 over 2, right, plus what? Plus 3. Plus 2, sorry. So that was 1 over 2, just like that. So this is it. When x is minus 1, y is equal to minus 1. When x is minus half, y is equal to what? A half. That was the condition of our question. So solving, guys, it's in your hands. You can apply any concept as long you understand what you are doing. The most important thing is understanding the stages or the calculations of what you're doing. So that is it. We can simply equate the two if y is the subject. All right, 1.3, given this, determine, so here it was to determine the value of x plus y from this. All right, let's see. 2 to the exponent of x over 16 is equal to 3 to the exponent of y over 3. But they said we must determine the value of x plus y. Okay, how is that possible? Let's see. If we are to simplify the left-hand side of our equation, remember, this is the base of 2, and 2 is in the simplest form. That is, we are dealing with a prime number there. So 2 to the exponent of x cannot be written in any way. It's just in simplest form. But 16 is not a prime number. As a prime number 2, it is raised to the exponent of what? Of 4. All right, these ones, they are in simplest form, guys. 3 and 3, this is just same as what? 3 to the exponent of 1. We can see that on the left-hand side, division, remember, same basis, x to the exponent of a, x to b is x to the exponent of a minus b. So you're going to subtract our exponents. So that's 2 to the exponent of x. We subtract 4 in that case, which is the same here, 3 to the exponent of y. Then we're going to subtract what? Subtract 1. These two, they are equal, guys. We are saying these two, they are equal. But take note, different bases that we are having here. Different. The bases, they are different. They are different. These two bases. But we are saying they are equal. How is that possible? So if we get back now to the understanding of our numbers, when the two bases, guys, are different like that, 5 to the exponent of x is equal to 2 to the exponent of x. 3 to the exponent of x is equal to, not to the exponent of x, but maybe to the exponent of y, whatever that you're given. 5 to the exponent of y, like that. The numbers are different and the bases are different. So automatically here, guys, for us to obtain same answer, it is only when the power is a 0. 5 to the power of 0 is 1. 2 to the power of 0 is 1. That is the only way. So 1 will be equal to 1. Which other power that we can use? No way. Unless we have what? A 0. So this is the condition of our question. As these two bases are different, the only thing that we can have to have the same answers here is that the power must be equal to 0. 2 to the power of 0 is equal to 3 to the exponent, which is 1 is equal to 1. That is the only way, because of these numbers that are different. So therefore, x minus 4, since we are supposed to have 2 to the power of 0, it means 2 to the exponent of x minus 4 represents 2 to the power of 0. So x minus 4 is equal to 0. That is what it simply means. On another case, the power of 3 is supposed to be 0 again. So therefore what? Y minus 1 should give us a 0, just like x minus 4. So in this case, you are going to solve for x and y. That is the condition. We're going to solve for these two. So that's x is equal to what? The minus 4 to the other side, so that's going to be a positive. And in our case, y is equal to what? A positive 1. These are values of x, value of y. Not what we are given here. The question is not find x. It is to determine the value of x plus y, the sum. Add those two, x and y, the sum. So adding these two, what are we going to have? X plus y is equal to what? We have the x value 4, we have the y value 1. So that was going to give us what? A sum of a 5. So the answer was supposed to be what? 5. Just like that, all right? So this is how these questions might be given as. Question number 2, given this sequence, which is, all right, they did not even give us, that's why they're saying if it is arithmetic or geometric, all right, no problem. So that is what you're given, guys. Remember the terms, first term, second term, third term, fourth term, and so on. So they are saying if the sequence is arithmetic, we must calculate the value or values of x and y. If it is what? Arithmetic. So what is it that we understand for an arithmetic sequence where it is linear? It is about the constant difference, which is the same throughout. We understand that the constant difference is the same throughout. So you can take advantage of the constant difference to say what is going to be the constant difference if we are given terms 81 followed by x followed by y followed by what? Followed by 3. As these are our terms t1, t2, t3, t4. What is the difference? So that is x minus 81 must be equal to what? Y minus x must be equal to what? 3 minus y. This is our constant difference. Throughout, it is the same. It is the same throughout. Meaning to say, if it is a number, if this is 2 is equal to 2 is equal to 2. So in that way, knowing that it is the same throughout, we can form equations now that we can use to solve for x and y. How are we going to form equations from this single equation that we are given? All right. How are we going to do that? We are simply going to equate one to the other two. So you can work with the first one, this one. All right. As for me, I'm just going to take the first one, equate it to the second one. It is the same. There's no way, guys. If it is 2, it is 2 throughout. If it is 3, it is 3 throughout. Also, equate it to the last one. That's what I'm trying to say is that 81, x minus 81, x minus 81 is equal to this one, y minus x, the second equation, y minus x, the second part of our equation. We have formed an equation where we can simplify. You can even simplify, make y the subject of the formula. We can take the minus x to the other side, so it's going to be what? Positive, all right? So if we make y the subject, that was going to be positive x. To get rid of this x, simply what? Add. So that's 2x minus 81 is equal to y, all right? It's an equation that we have. Just leave it like this. Let's call it equation 1. We can also say the same x minus 81 or the same x minus 81, x minus 81. One that we used here, the same, it is equal to the last part of our equation, which is 3 minus y. So just like the previous case that we had, we can even make y the subject of the formula, because y is the subject here. It's going to be easier that way. So to make y the subject, take it to the other side, it's going to be positive y there is equal to x to the other side. That was going to be negative. This was going to be positive. So it was going to be negative x plus 81. But remember, there's already a 3 on the right-hand side. So combining this, that's minus x, 81 plus 4, which is what? 81 plus 3, that's 84. So that's our second equation. Y is the subject here. Y is also the subject. So you can simply equate the two. All right. So simply equate equation 1 to equation 2. All right. So that is equating these. We are simply saying what represents y from equation 1, 2x minus 81, is the same as what represents y in what? Equation 2. Those two can be equated. So that's 2x minus 81 is equal to what? Minus x plus 84. So we can solve for x, as we only have x in our equation. So taking x to one side of the equation, we can take the minus x to the other side. That was going to be positive 2x plus what? Plus x. Positive. Okay, let me write 2x plus x. The negative 81 to the other side was going to be positive there. So that's 84 plus 81. All right, so this is 3x is equal to 84 plus 81. That was going to give us 165. So dividing by 3, we've got our value of x, which is what? 55. With this value of x, we can substitute in any one of these two equations, as y is what? The subject of the formula. We can substitute in any one. So I'm going to use equation 1. Y is equal to what? 2x minus 81. Substituting in that equation, which is our equation 1, we can obtain the y value for the value of x, which is what? 55, as we are given. So that's 55 here minus 81. So that was going to give us the value of what? Of y in that case. Use your calculator properly too. Into 55 minus 81. That was going to give us what? 29. So that's it. For this to be an arithmetic sequence, x must be what? 55. Y is supposed to give us what? 29. So you can even test those values by putting back into your sequence and see if truly we are going to have the constant difference, if truly it is what? An arithmetic. So there are so many ways, okay? Just try other ways and see if you are going to have the same answer. And as you are going to check also the memo of the question paper, you can also opt for other methods or ways that you understand, all right? So that was it on the first part of our question 2. The second part of our question 2, this time they're saying we must find x and y if it is to be considered as a geometric what? As a geometric sequence. So the idea is still the same, forming of equations, but how can we form an equation when it is what? A geometric sequence. We can use the understanding that in a geometric sequence, we have got what? The constant ratio. So that ratio must be the same. Remember the constant ratio x over 81, y over what? Y over x is equal to what? 3 over y. Term 2 over term 1, and so on and so on. So if this is the same throughout, we can simply use the previous condition, working with the one, equate it to the other two. So using the first one, we can equate it to the second one, or we can equate it to the what? To the third one. So therefore, x over 81 must be equal to what? Equating to the second, that's y over x. Or x over 81 must be equal to the third part of our equation, which is 3 over what? Which is 3 over y. Just like that. So this is what you were going to have. Okay, let's try to solve. We can make y the subject again, just like the previous one, because we can see here, it is easier to make y the subject from our equation 1. Simply multiply by x, multiply by x. That was going to cancel. So that's y is equal to what? X times x, that's x squared over 81. All right, making y the subject on this side of the equation, it means there was a need for us to first interchange. As you can see, y is in the denominator, guys, so you can just interchange, also interchange here. So it means 81 over x is equal to y over 3. You interchange so that you can simply multiply by 3 to get rid of this 3 in the what? Denominator. So that's y is equal to what? 3 times 81, that's 243. 1 times x, that is what? X. So y is the subject. So we have got equation 1, y as the subject, equation 2, y as the subject. So simply equate the two just like the previous one. So equate the two equations, equation 1 to equation what? To equation 2. Where y is the subject here, x squared over what? X squared over 81. And where y is the subject here, 243 over x. They represent the same thing, those two. So if they represent the same thing, simply equate them. Simply equate them. So x squared over 81 must be equal to what? 243 over x. So we can solve for x as we have got one unknown value. One unknown, which is x, So here cross multiply to get rid of the fraction. X squared times x, that's x to the exponent of 3. Remember, you add exponents. 243 times 81, 243 times 81. That was going to give us 19,683, right? 19,683. So we can determine the cube root since this is to the exponent of 3. So determine the cube root. The cube root, both sides. This was going to cancel. X is equal to what? The cube root of what we are given, that is from our calculator, the cube root. Simply shift the cube root and on that square root. We have got what? The cube root there of what? Of the answer. So that's 27. So x is equal to 27 for this condition that we given x is supposed to give us what? A 27. So what about the y value, the value of y? From any one of these two equations, you can substitute, find the value of y. All right? Any one of these two equations. All right? So using equation 2, y is 243 over what? 243 over x. So where x is 27, that's 243 over our x, which is 27. That was going to give us the value of y, which is 9. So that is it. Y is equal to 9. X is equal to what? 27 for the condition that we are given as a geometric what? As a geometric sequence. Constant ratio. The ratio that we are having or that we to find is the same throughout if it is what? A geometric. So that is how we can simply attempt these typical questions just like that. We just have to try, do more questions. 2.2 as part of our quadratic, as part of our sequences, we have a quadratic pattern. And they said the first 4 terms are given. Determine the nth term of this pattern. All right, that was a direct question actually for a quadratic. For a quadratic, this is one of the direct questions. Anyways, how can we determine the nth term, the Tn, which is an squared plus bn plus c? We are given our terms. We are given our terms. In this case, simply determine the differences. All right, these are the terms. Determine the first differences from our terms. 591 minus 661. 591 minus 661. That was going to give us negative 70. The same here, negative what? Negative 70. 525 minus this, you're going to obtain negative 66. This one minus this one, you're going to get negative 62. So those are your first differences. Remember, we must also determine what? The second differences from there. Determining the second differences, that was going to be negative 66, negative 66, minus 70. Minus or negative 66, we are subtracting negative 70 from that. That was 4. The same thing, this one minus this one, it was going to also give us a 4. So with this, we've got our second what? Second differences. And what is important are these numbers, the 4, the minus 70, 661, as this is equal to 2a. This is 3a plus b. Remember, this is a plus b plus c. Just like that, all right? So like I said, this was one of the direct questions because we can determine our a, b, c from there, all right? If 2a is equal to the second difference, that is equal to what? To 4. A was going to give us what? 2. All right, let's solve for b from the second part, that is the first differences. The first term of the first differences must be equal to what? 3a plus b. 3a plus b is equal to negative what? 70. Since we need b, that's b is equal to negative 70. 3a to the other side, that's negative what? 3a. So that's our b was going to be negative 70 minus 3 times our a, which is what? Which is 2. All right, so this is it, guys. That's negative what? 72. 3, 3, 3, 3, 3, 3, 3. Where is the 3? There's a 3 here. There's a 3. That's going to be negative 76. All right, so b is going to be negative what? 76. So you can just use the calculator direct here. All right, 70 minus 70 like this on your calculator. Minus 70 minus what? 3 open bracket minus 2 like that. That was gonna where am I getting the negative 2? This is positive 2. So that was gonna give us negative 76. All right, another one from a plus b plus c, which is equal to what? 666. A plus b plus c, 661. Let us find c from there. Simply means that c is equal to 661 minus A minus B, minus A minus B. So the 661 minus what is the value of A? That is 2. Minus B, what is the value of B? Minus 76. So that was it. We are going to have the value of C from there. 661 minus what? Minus 2 minus what? A negative 76. So that was going to give us 735. With the value of A, B, and C, we can substitute them back into our Tn formula. So that's we're going to have the nth term of our given sequence Tn from an squared plus bn plus c. That was going to give us what? Tn is equal to what? 2 in place of a, 2n squared minus 76n plus what? 735. So this is it. As we can see, we were going to have that as our quadratic. And it is important, guys, that you understand all these basics. All right. Calculate the value of the lowest term. The lowest term for 3 marks. All right. So remember, guys, this is a quadratic. And if it is a quadratic, it means whenever we're talking about maximum values, minimum values, we must understand. Because if it was like y is equal to 2x squared minus 76x plus 735, you're going to draw a quadratic function, isn't it? A quadratic graph, which is because of the coefficient of x squared, which is a positive value, it was going to be concave up like this. And for a concave up, we have got what? The minimum value at the turning point. It is the minimum turning point. That's why they are talking about the lowest value, is because of the type of the graph that we are talking about there. It gives us what? Minimum possible value. The condition where you find that minimum value, y is equal to what? It is the same thing here, but it is what? Tn. So the question that we are to determine, it is to find the value of Tn, to say what is Tn, our Tn at the lowest value. So what is that we can use? We can simply use, just like quadratic functions, x is equal to minus b over 2a. We can use the derivative concept, the derivative f of x is equal to 0, for us to determine what? The value of x at the turning point, whether it's minimum, whether it's maximum, same concept. So you can use the derivative concept, or you can use the minus b over 2a. So since we are talking about n in place of x, we are talking about n. So n is equal to minus b over 2a. N is equal to minus our b. This is A, B, C. So our B is what? Negative 76 over what? 2 times our A, which is 2. So that was going to give us N, which is the number of terms, like to say at which term are we going to find that from 19? T19 is what? We are talking about the 19th term, T19, when N is 19. Just like here, to say when you find the value of x, x is equal to 19. What about the value of y? You substitute x in place of what? In place of x. That is the condition. So T19 simply means in place of n, substitute what? 19. So that's 2 into 19 squared minus 76 times what? Times 19 plus 735. So we have substituted the corresponding value of n into what? Our formula from the 19 that we are given. So that is going to give us the corresponding minimum value, or the corresponding lowest value of our given what? Sequence. So that's 2 into 19 squared minus 76 into 19, all right, plus 735. That was going to give us 13. So that's T19 is the lowest. I mean, T19, which is equal to 13. That's our lowest value that we can ever have from that sequence, or from that quadratic pattern that we are given. So a quadratic pattern it is still the same, just like a quadratic function. So it has the properties of a quadratic function. That is why we can use that concept, or you can use the derivative. Since it is much, guys, most of you won't be knowing about these derivatives. So that is why I'm not explaining about those derivatives. But if it is for a June exam, you'll be have done derivatives. In that way, you can even use your derivatives in as much as you want. 2.3, we are given that this is a combination, all right? An arithmetic sequence is given such as, all right, determine the common difference between each term. Determine. This is an arithmetic sequence, but as a combined sequence. If you check properly here, it is a combined sequence at the same time. It is a combined sequence. The combined sequence part here is that we are dealing with terms under odd and terms under even. They were combined together to give us an arithmetic. Anyways, each part is still representing what? An arithmetic. But they separated odd terms to even terms, 2, 4, 6, and so on. These are even terms. So the question was to determine the common difference. Just consider to say, all right, starting from 1 to 2013, how many odd terms do we have? Because yet they are being added, the sum is there. The sum of odd terms is already given as what? 3029. The sum for the even terms is already given as what? 6050. What we need now is to know how many terms are there for odd numbers. The last number that we have is 2013 on odd numbers. So remember, to find n for odd numbers, it's going to be 2013 over 2. But as you can see, we're going to get a decimal. So whenever there's a decimal, we must what? We must round up. So that's 2013, 2013 divided by 2, which is what? That's 1006.5. So 1006.5. We round it up. By rounding up, that means our n was going to be 1007 the next term. So that's 1000 and what? And 7. Our n for odd numbers. This is for odd numbers. We're talking about odd numbers only here. So n is going to be 1007. For even numbers, our n from the last term that we have 2014, if we were to divide 2014 over 2, guys, that was going to just give us a direct number, 1007. So it means we have got 1007. When you obtain a whole number like that, there's no need for you to say you are going to round up or round down. But if it was, let's say we are dealing with a decimal, you are going to round down for what? For even numbers. You round up for what? For odd numbers. All right. So that is the only part that we know so far to say it is an arithmetic. We've got the sum, and these are what? This is our number of terms. Also here, our number of terms. Then another thing is the difference. If you check under these odd terms, it will be like this. The first term is A. The third term, it will be A plus 2D. Remember, A plus D is not the A. A plus D is for what? Is going to be on the even on T2. This is our A plus what? A plus D. A plus 2D. A plus what? 3D here. A plus 3D, T4. T5 is going to be A plus what? 4D. A plus 5D here. This one is going to be A plus what? 6D. These are how the terms will be given as. So meaning to say, the difference, if we check between these odd, if you had to check the difference, it was going to be 2D minus 0 there, which is 2D. It is like this, A plus 2D minus A. So this one cancels. We have a difference of what? Of 2D. Use even T5 and T3. You're going to find this. You're going to get the same thing. a plus 4d, we subtract what? What are we subtracting? A plus 2d. So it was going to be a plus 4d minus a minus 2d, a difference of what? 2d again. So that's a difference of 2d. So meaning to say, where there is where we put that common difference or the constant difference, in our case, we are going to put it as what? As 2d. As 2d. It is 2d. Okay? So that's the same thing even for the even terms, because they'll be separated 2 units from each other. 2, 4, 6. So you're going to have the same thing. 3d minus d is what? 2d. Because the a and the a will cancel. So 3d minus this d, there was going to be also a difference of 2d. 5d minus 3d, a difference of what? 2d again. So even here, our difference is going to be what? 2d. So noting these guys is important. Why do we want this? We want to calculate for d. We want to calculate, the constant difference, remember, of each term, between each term. So as we have got the sum, remember the sum formula, we are dealing with what? An arithmetic. And the sum formula is given for an arithmetic. If we go back here, I want us to see what we have here. The sum formula is given if you are to use this formula, or you can use the Sn, n over 2 into a plus what? Into a plus l. All right, that will be up to you in that case. All right, so using the one in the formula sheet, I want us to see here. Since the sum of terms, so it means the sum of odd. All right, let me just write the formula first. Sn, n over 2, 2a plus what? N minus 1 times d. So if we are referring to the sum of odd terms, as of the odd terms, we are saying the sum of odd is what? 3029. Let me just write it because we already have our formula here. The sum of odd is what? 3029. 3000 and what? 29. That must be equal to n over 2. We have the number of terms. N is what? 1007 over 2. Into 2a, we do not have, or we do not know our a. Our first term, we are not, so we're just going to write as 2a plus n minus 1. We remember our n, we have it 1000 what? 1007 minus 1 times d. This is the part that I was explaining about this d, to say you must consider the difference as of the sequence that you are given. And if we consider that, it is what? 2d. So meaning to say, in our case here, we are going to use 2d. All right, 2d. From the differences that we obtained, there's a difference of 2d throughout. So we have an equation that we can simplify and see where it is going to end. But as you can see, there are two unknown values. So it is the same thing that you're going to do even for what? For these even terms, because you know their sum is what? 6000 and what? 6050. So 6050 is equal to how many terms? N over 2. 1007 over 2 into what? 2a plus n minus 1. Our n, 1007 minus 1 times what? Times d. Our difference is what? 2d. So that's it. As we can see, we have also two unknown values, a and d. But okay, so let us just try to simplify them and see where we can end, because we can see that here there's something that we can play around. All right, to get rid of these 2 that's in the denominator, simply multiply by 2, multiply by 2 here. This was going to cancel. So you are going to have 6058. 6058 is equal to 1007. All right, that's into 2a. All right, this is 1007 minus 1, which is 1006 times what? Times 2d. So 1006 times 2, that was going to give us 2012 times what? Times d. Okay, so there's something about 2a, and what is going to remain inside the bracket. So let us just try to have it, this 2a plus something, 2a plus something. So to have that, let's simply divide by what? 1007. This is what we are also going to do here. So as we are solving, you can see that that is going to be an important part of our equation. This is going to be the important part of our equation. So the left hand side, you can simplify it or just leave it as it is, as a fraction like that. I want us to see something that was going to happen here because of this part of the bracket here. Let's have something like this. Let's try to have something like that. So to have something like that, we are going to do the stages just like here. Multiply by 2 to get rid of that 2 in the denominator. So that was 6050 times 2, which was going to give us 12,100. 12,100 is equal to what? 1007 into this bracket. So if we're to simplify this, guys, we're going to obtain 2a. This is going to give us 1006, just like the previous one, times 2 times 2d, which is what? That's a positive 2012. 2012d. All right, so as you can see, it is the same part that I wanted, guys, this one. So that was it. That was it. That was it. That was it. All right, another thing here, guys, about our a. Sorry for that. For the odd terms, our a is okay. That's another thing. Our a represents t1. Our a represents t1. Our a is equal to a, just like that, because that's our first term t1. But as of the even, let's correct this. Very sorry for this, guys. As for a, for the even terms, our a is what? T2. Our a represents T2. That's the for the even terms. And the T2 is gonna be what? A plus D. So that's a plus what? A plus D. That will be your first term for the odd, I mean for the even terms. Your first term is what? Is T2. And it is what? A plus D for an arithmetic. So that was going to affect our question. Very sorry for that, guys. Very sorry for that one. So here you must have A plus D here to represent our A, the first term, A plus D. So that was going to affect everything here. Let's also correct this part. So it was going to affect everything. That's 2 times A, which is 2A, 2 times D, which is what? 2D. Okay. Then these two, all right, it's fine. 1006 times 2 is going to be 2012. All right, so that's it. 2012, what? D. There's a D there. So that is what you're going to have. And just like the previous case, divide by what? 1007. 1007. That was going to cancel. Right. So meaning to say, on the left hand side now, we have got 12,100 over 1007. And the right hand side, the alike terms there, the part of what? The part of D. There is 2D, there is what? 2012D here. So meaning to say, that was going to give us 2A plus 2 plus this 2012, that's what? 2014. So that was going to be 2014D. Okay, just like that. So you must be very careful there. So these are the two equations. We can work with equation 1, equation 2. All right, so you can say this is equation 1 and this is what? Equation 2. So in order for us to solve, remember we are supposed to solve what? For D. The question is for D. So in order for us to solve this, we can simply get rid of the 2a, the 2a, the 2a that we see there. So in order for us to get rid of that 2a, we can simply subtract the two equations, whether it is equation 1 minus equation 2 or it is equation 2 minus equation 1. It's up to you. So if we subtract equation 1 minus equation 2, that means This was gonna subtract this one. All right, 6,058 over what? 1,007. We are going to subtract equation 2, 12,100 over what? Over 1,007. So that was going to give us negative 6. So that's negative 6 is equal to the 2a, and the 2a was going to cancel. So it's now 2012 minus 2014. 2012 minus 2014 is what? Negative 2. So that's negative 2d. To find d, simply divide by what? By negative 2, by negative 2. So therefore, we have got our d as what? 3. So that was going to give us a positive 3. So this is what you're going to have. So to answer these questions, guys, there are so many ways, but okay, just look for ones that you feel like this is easier to follow up. In our case, that is what we had. We just need to be very careful on the last on that segment of A there, on the even terms. For the even terms, your A is what? It is T2, and T2 is represented by what? A plus D for an arithmetic sequence. Here it was A representing what? T1 as of the odd terms. That is our T1. So that is A. Remember, this is A as it is A plus 2D, A plus 4D, A plus 6D. But for the even terms, your first term, the one that you're saying, it is my first term for the even terms, it is T2. And it is given as what? A plus D. So that affects now here. But this one is not affected. Okay, so yeah, these are questions, but for 3 marks, is for 3 marks. Even if you had to check other methods, you see that for 3 marks, it was not even fair enough. All right. So, anyways, guys, let's see. Question number 3. Prove that this summation converges. All right, where we have an infinity there. All right, once an infinity is given, guys, it simply means it converges. But here they want us what? To prove it. So to prove that it converges, since it's a geometric, we just need to deal with what? The ratio. The constant ratio R is supposed to be greater than 1, but less than 1. So let's determine our R in that case. For the values of K that we have, T1, when K is 0, is going to be what? In place of K there, you put a 0. So that was going to be 7 times what? Times 3 to the exponent of what? 2 minus 0. That's 63. So this is 63. T2 is going to be what? When K is what? When K is 1. When K is 1, we put a 1 in place of a 0 here. That's what? 21. There's no need, guys, for you to obtain third term, this and that. Already, for you to prove that it's a geometric, it's from where? For you to prove that it converges, it's from a geometric. It's a geometric already. So we know that we deal with what? With R there. So R being the second term over the first term. That's 21 over 63. And that was going to give us 1 over 3. 1 over 3 is actually a number which is greater than 1. So this is correct. And 1 over 3 is less than 1. So this is correct, guys. So meaning to say, therefore, it converges as 1 over 3 is greater than minus 1. It is also less than 1. So therefore, it converges. Okay, so hence determine the value of M on this condition that this summation from K is equal to M is supposed to give us this. So guys, this is the same presentation as before. So whether you start at 2, at 3, at 4, and so on, that is not going to change anything because of what? The terms will give us the same ratio throughout. The same ratio, same ratio, same ratio. So our R is not affected, which is representing what? The constant ratio. This is not affected. What is affected is the first term, where you are starting. You are starting from where? K is equal to M, so A representing our first term is going to be, here we just put M there. So it's going to be 7, 3 to the exponent of 2 minus M, because we are starting with what? With M. That's our starting point. Where are we ending? For how many terms? Up to infinity, guys. So up to infinity, we are calculating what? We are calculating the sum to infinity. That is the case. So what is the sum to infinity as a formula that we are used to? The sum to infinity as a formula that we are used to, it's A over what? 1 minus R. This is our formula. So we are going to use that formula since we are dealing with what? A sum to infinity. It is what? A over 1 minus R. So since it is there, because this whole part represents sum to infinity, which is what? 21 over 2. That's our answer, is equal to what? A, the first term, in terms of M. That is where our M is going to play a role. 7 times 3 to the exponent of 2 minus M. All right? Everything over 1 minus R, our R being what? 1 over 3. So this is it, guys. In order for us to solve here, what I'm going to do, guys, is just get rid of this denominator as it is. So I'm just going to multiply by 1 minus a third. Here, multiply by 1 minus what? A third. So that I simply get rid of this. I'm left with 7 times 3 to the exponent of 2 minus M equal to the left-hand side where I have got what? A bracket of 1 minus a third. 1 minus what? A third. All right. Then multiplied to what? 21 over what? 21 over 2. So that was going to give us a 7. All right. This is direct 7. So the 7 is equal to 7 times 3 to the exponent of this. Get rid of the 7 as a product. Simply divide by what? Divide by 7. So 3 to the exponent of 2 minus M is equal to 7 over 7. That's 1. All right, same basis for us to equate the exponent. But which base, guys? To get a 1 in the base of 3, it is 3 to the exponent of what? Of 0. 3 to the exponent of 0 is equal to 3 to the exponent of 2 minus M. As these two bases are the same, simply equate their exponents. So therefore, 0 is equal to what? 2 minus M. That's it. We can solve for M. Taking that to the other side, it was going to be a positive 0 plus M, which is M is equal to what? To 2. Just like that. So we can solve these. We can actually do solve this. Just you have to be careful, guys, on your calculations. All right, just like that. Summation. Guys, let's revise as many questions as we can. That can actually help us to prepare for these exams. So looking into this question, we are having question number 4 where they're saying it is sketched below. All right, sketched below is the graph of what? Hx. And that's 3 to the exponent of x minus 9. That's our hx. For the values of x being taken from minus 3 to 2, they gave us the domain for that, meaning to say we are going to consider our x values -1, -2, -3, +1, +2. All right, when it is +2, that's a 0 there, 2, 9, so that's 2 here, and somewhere 1 there. All right, and we do understand that we have got a -9 as our asymptote, meaning to say our graph is limited to the -9 for the what? For the y value that we are given. Okay, so that was it, guys. With this function, we can attempt our questions. Let's see the questions. Let me just indicate this one so that we can see properly what we are dealing with. So this is it. our function that we are given, which is under our exponents. All right. So that was it. Okay. So the questions were just direct also. 15 marks. All right. There was a lot, but they were direct here. 4.1, you were given to write down the equation of the asymptote of h, all right, of which I have already indicated this one. Y is equal to what? -9 on our diagram. So that was direct, this one. Then determine the coordinates of a being what? The x-intercept, all right? We're just looking there, guys. We can tell that a is equal to what? Oh, no, 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 no. Hey, guys, look, I'm focusing on b. This is what? This is a, not b, all right? So we need a, this one, which is the y-intercept. So the y-intercept, we understand x is equal to what? To 0 in this equation, or on the line that you're given. The y-axis as a line, x always is equal to what? To 0 there. So we can take advantage of that one. So that's our 4.2 at a. X is equal to 0 as it is the y-intercept. So y is equal to what? In place of x, just put a 0 there. So that was going to be what? 1 minus 9, which is -8. So that's therefore the point A is what? 0 minus 8. As a point, x is 0, remember, y is -8. 4.3, we are now given that is determine the equation of the straight line G if G is passing through A and B. G is passing what? Through the points A and B. All right, so we have got the point A. Let's have B here. I'm just going to try to have a line to represent what we are given this time. So that is something like this, from A passing through what? Passing through B. A line was drawn. What is its equation? That is the question that we are given there. All right, so what can we use to determine this equation? So we need the equation of the line what? AB. Points. A being the y-intercept, we have this point, remember, 0 minus 8 as we calculated before. Then we can also determine the b. Already b is 2, where y is equal to what? To 0, by just looking into that equation. 0 is equal to 3 to the exponent of x minus 9 to the other side. That's 9 there as a positive, all right? Equal to 3 to the exponent of x. So 3 to the exponent of 2, 3 to the exponent of x. The bases are the same, so x is what? Is 2. So that is it, guys, that we see there at b. So b as a point, that's 2, 2, 0. So remember, for us to have the equation of a straight line, guys, we can use y is equal to what? Mx plus c, where c is the y-intercept. But m is the gradient, which we can calculate or determine by just moving the increase in y over the increase in x. So we can have our m, the change in y, over the change in x. Using this one, you were going to get the change in y going up. That's +8 as you are going up. Increase in x, we are going to the right, that's +2. So that was going to be 8 over 2, which is 4. So you have got your gradient. Or you can use the formula, m being the change in y over the change in x. That is what? Y2. All right, y2 minus y1 over x2 minus x1. You can use any formula that you wish to apply, as long you are to consider this part. As you can see, m is given as our gradient, and thus from the formula we can use y2 minus y1 over x2 minus what? X1. So that is it, meaning to say we need to name our points x1, y1, x2, and y2. So that is x1, y1, this is x2, y2. So putting in y2, that is what? Negative, y2, that's a 0 there, minus y1, which is what? -8. Everything over x2, which is 2, minus x1, that's a 0 there. Simplifying this, you're going to get +8 over 2, and that's what? A 4. same answer as before. So having this gradient, we can determine our equation as y is equal to m, which is our gradient. So that is 4x plus c. That is the y-intercept. Guys, we have it. The y-intercept, the graph, or our line here, which is our linear function, crosses what? The y-axis at what? -8. So that's the value of c, the y-intercept. So therefore, y is equal to what? All right. Before that, remember it is given as h. Is it h? All right. Let me check. That's -8. They said it is the equation of what? The straight line g. All right. So that's g of x. So that's g of x. Therefore, gx is equal to what? 4x minus 8. Okay. So you were given something direct, as you can see, you could work from the diagram to calculate your gradient or to use the points in order for you to have the gradient. Then write down the equation of mx if mx is this one. So guys, we can simply write this one because we have got hx, remember? So they are saying mx is equal to hx plus 9. So you just take your hx as it is. Remember, we have it hx as it is 3x to the exponent of 3 to the exponent of x minus 9. You take it as it is 3 to the exponent of x minus 9. That's our hx plus what? Plus 9. So you must add the 9 that is part of your transformation that you're given. All right, minus 9 plus 9, that's a 0. So that was going to cancel. So therefore, our mx is what? 3 to the exponent of x. Just like that, okay? Another question, 4.5, write down the equation of the inverse of m in this form. All right, already we calculated mx here. We have it. So that is y is equal to 3 to the exponent of x. So the inverse of mx, remember, first thing is to interchange x and y. You must interchange those. So that is, we are going to have this as x, all right, is equal to 3 to the exponent of what? Y. You interchange. Then you make y the subject of the formula. Make y the subject of the formula. Remember the steps where from our logarithms concept, we do understand that if we are given log a in base of b equal to c, this a here is equal to b to the exponent of what? B to the exponent of c. So we have this in our exponents, convert it to a log. We can see that our exponent c will be the subject of the formula. Our exponent is what? Is y. So y is going to be the subject. It will be y is equal to, all right? So that's it. The logarithm of what? Of a, the a is what? Is x. Logarithm of x. In the base of b, our b is what? 3. In the base of 3. That must give us a c, the exponent. Are we seeing that? Our exponent is what? Is y. So y is the subject. So that is it. They said we must write this equation in the form y is equal to. All right. So in that format, that is it, guys. Y is equal to what? The logarithm of x in the base of 3. That is it. Then 4.6, write down the range of the inverse. Remember, guys, what happens between the original function for the mx. The mx, this is our, they are saying this is the inverse of mx, and mx is being taken from here. This is our mx, which was as a transformation from where? It was transformed from the original graph, this one. All right, we shifted the graph. If we say plus 9, we are shifting the graph up. So shifting the graph up or down, all right, if we shift the graph up, so it is the same effect that can also happen when it is going down. Same effect. So the effect here is that we are going to have the original function. From the original function, the domain will remain the same. So in terms of the effect, we are saying our domain is not affected, guys. When you take this graph up, let me try to see if this is a single thing. All right, no problem. Let's say it was here as the whole graph, and you are taking it up like that. As you are taking it up, you're taking it up, or you're taking it down like this. You're taking it down. It is in within the domain -3 to what, to 2, that you are going to consider. So meaning to say, mx, its domain from where it was transformed, it has a domain which was taken from where? According to where it was taken from. Because here, the problem of a conditional question, you don't answer it from what you have been taught to say, all right, the domain for this type of a graph, it is just any real number. No, they gave us a condition, so you must also consider that condition. So it must be taken from the same domain that we had of the original function. It was not affected as we are taking it up or down. It is only the y values that are affected. When you shift it up, the y values are affected. So meaning to say, it will affect our asymptote is going to be affected. All these, the range also will be affected, not the domain. So meaning to say, to answer our question now, because they want us to write down the what? Sorry, here it is what, 4.6. They want us to write the range of what? The inverse. But here I'm talking about what? The domain. Why am I talking about the domain? Remember that the inverse, this inverse of m, was taken from what? From mx, which means it was transformed along the line y is equal to x. Remember what happens along the line y is equal to x on that transformation? It is a swap transformation. What does it mean? You swap everything. So if we swap, or if we change, if we swap x, it changes to y. The moment you have it as y taken from -3 to 2, what are we talking about there? Y values. We're talking about the range. So meaning to say, the domain interchanged is now giving us what? The range for the inverse. We swap everything. All right? Just like that. All right. 4.7. C is the result of what? Of point A when reflected over the line x is equal to 2. Calculate the area of triangle ABC. All right, let's start by that. C is a point. C is this one, point C. It is a point, which is as a result of point A when reflected over the line y is equal to, with the point A was reflected. Let's go to the point A and see. This is where our point A is, all right? Let's just see what we have here. Okay, this is our point A from our graph. So the point A was reflected along or across what? Over the line x is equal to 2. X is equal to 2. So x is equal to 2, that's what at B. Remember B, x is what? Is 2. So if we reflect over that line, it means we had something like this. All right, let me just draw the line. X is equal to 2. It was like this. This is the line. X is equal to 2 is what? It's a vertical line. So remember the transformation over a vertical line. What happens if you transform a point over a vertical line? It moves the same distance. The point A moves horizontally to that line, which is our mirror line, and moves the same distance to its image, because A is this side of the mirror line. This is our mirror line. So the image point will be on the other side, but it will move same distance in that horizontal line from what? From A there, horizontally. Okay, let me indicate it this way. horizontally from A. We must take it from A horizontally like this from A. It will move same distance to the mirror line. This is how this transformation works. So it moves same distance. The number of units moved up to the mirror line is the same number of units that you're going to move to its image point. So this is what we want to know. How many units from A to the mirror line? How many units? That is the x value at what? At B, since A corresponds from the origin. So from A, all right, let's just do this. This is 0 minus 8, guys. Do not forget. This is what I want you to see. So from A at 0 in terms of x to B, which is 2, the distance there is what? 2 units. 2 minus 0. Remember, x value at B minus the x value at A. So meaning to say we had a distance of 2 units there. 2 units from this point to the mirror line. From the mirror line to the image, also you must move 2 points. 2 units, I mean. You must move 2 units. So meaning to say, if this is 2 horizontally, if we add another 2, we are going to end up at what? At point 4. So the point that is representing the x value is going to be 4. Meaning to say the point here is 4 versus what? Guys, we know something that is common about this. Remember, at point A, it is what? 0 minus 8. Meaning to say y is the same throughout this horizontal line. Y is equal to what? Y is equal to minus 8. So at the point of our image, which is the image of A at that point, y is what? Negative 8. We know that one from what? Because this was moving horizontally. So this is where the image is. So the question here is that we must determine the area of the triangle formed ABC. All right? Oh, sorry, it is reflected to what? To C, not A bar, but is what? C. So find now the what? The area of triangle A, B to C. As we can see, from A to B to C, it is a triangle that is going to be formed. If we join B to C like this, that's we have formed what? A triangle. We are forming a triangle. And this triangle is actually a right angled triangle at the line of symmetry. It is an isosceles triangle in actual sense. What I want you to see here is that x is equal to 2 is a vertical line. Y is equal to minus 8 is a horizontal line. So meaning say these two, they meet at what? At 90 degrees. So you can you can calculate the area of a right angled triangle like this. This is A, this is A, this is B, this is C. This is a perpendicular height from B to this point. Remember, from A to x is equal to 2 units. This one also 2 units. Same distance, 2, 2. So 2 plus 2 was going to give us how many units? 4 units. From A to C, we have got 4 units. What about the perpendicular height? Do we have it? The perpendicular height, it is representing the y values from B to this point. What is the height? You simply work with the y values. The y value at B, it's 0. Remember, y is equal to 0 there. And the y value at this point is what? Minus 8. So the difference, 0 minus minus 8, that's 8 units. So our perpendicular height is 8 units from 0 up to minus 8. All right? So meaning to say we can calculate our area by knowing this. Perpendicular height is given. So therefore, our area was going to be calculated. That's our area of triangle ABC, as we have got the base and the perpendicular height. That's half base times what? Times our perpendicular height. So that is half of the base, which is what? Which is 4, times the perpendicular height, which is what? Which is 8. So that was it, guys. Half of 8, that is 4. 4 times 4, that is what? 16. So it was going to give us 16 square units, just like that. So you see, guys, they play around with you guys. Okay, you understand the area, but when now you're given it as part of these functions, can you locate that area? The transformation concept point was reflected. All that you must understand. All right, so that was question 4, having 15 marks at the end. All right, question number 5, they gave us a hyperbola and it is given in the form minus 2 over x plus p plus q. The equations of the axis of symmetry of f are these. All right, so that's the one with the negative gradient and the one with the positive gradient. Remember from the asymptotes concept, we have got the axis of symmetry, one with a positive gradient, one with a negative gradient, which meets at the what? At the intersection of our asymptotes. All right, no problem. Determine the values of P and what? Q. P and Q represents what, guys? P and Q, that is the part of our asymptotes. So here we are simply going to find the point of intersection of what? The axis of symmetry. All right. P and Q. Not P, but X and Y. There will be X and Y there. The value of X and Y here at the point of intersection, it is where also these asymptotes pass. So it is actually representing what? The asymptotes. So here, guys, they just wanted you to play around with these two equations. As you are given what? The axis of symmetry. Simply solve these two simultaneously. All right, so that's it. That's it on this part. Let's find x and y first. X and y first. So solving these two equations, y is equal to minus x plus 8. That's our equation 1. Equation 2, y is equal to x plus what? X plus 2. Guys, we can simply eliminate y or eliminate x. It's up to you. To eliminate y, we can subtract the two equations. All right, let's try to eliminate y. So subtract equation 2 from equation 1. That's we're going to subtract these two. We have got what? We have eliminated y. Y minus y, that's a 0. It is equal to what? Minus x minus, remember we're subtracting here, minus x minus x. That's minus 2x. 8 minus 2, that's what? A 6. So to solve for x, we can take this to the other side. That will be 2x is equal to 6. So divide by 2 by 2. It means x is equal to what? X is equal to 3. Let's solve for y. In that case, y is equal to what? Minus x plus 8. Anyone take one of the two equations, substitute the x value that we have. So that's minus x plus 8. I'm going to use the first one. So y is equal to minus, our x is what? Is 3. Then we're going to add 8 here. So that was going to give us minus 3 plus 8, which is what? Which is a 5. So y is equal to 5. X is 3. So let's determine the values of P, guys, because the value of P and Q. Remember that Q is the asymptote for the Y, which is not affected, as you are referring to the Y value as it is the asymptote. It was going to be Y is equal to Q. So Q is the value of Y as it is, which is 5. So Q is not affected. Q is going to be 5. But as for P, it is affected because remember when you are finding the asymptote, whatever that you be having, the value that you be having, x plus p is equal to 0. So it will be x is equal to minus p. If it is x minus p, you solve x is equal to what? Positive p. So whatever that you have as the value of x, as the value to say x is equal to, when it is substitute, it changes the sign. If x is equal to minus p, when substitute, it changes the sign. So in our case, our x value is what? Our x value is 3. So that means our p is supposed to be what? A negative in that case when substituted to say x is equal to 3. But from here, from the format, it is x minus p. All right? So our p is supposed to be what? A negative 3 there. We must have a negative 3. So that is the condition that you must also put into consideration. And in our case, if we were to write down this, it's not that they never asked you to write, to rewrite whatever, but this is what I'm trying to say. It was supposed to be like this: x minus 3 plus 5. When they say determine the asymptote, the equation of the asymptotes, you're going to say x minus 3 is equal to 0. X is equal to what? To 3, which is this one. Which is this one. So as of p, be very careful, it will be minus there. All right, just like that. So then after that, they want us to sketch. All right, just like that. No. There's something here. 5.2, if p is minus 3, exactly what we have there. Q is 5. Determine the coordinates of what? X and Y intercepts. So thus we are going to work out with our equation. I mean our function f of x. Remember, we have got p and q now. So the x-intercepts can be determined. All right. So that is it. 5.2. Let's start with x-intercept. Y is equal to 0, remember? So that's when y is equal to 0, you're going to have minus 2 over x minus 3 plus 5. We solve for x. The 5 to the other side is going to be a negative. So negative 5 is equal to minus 2 over x minus 3. Solve for x. This is same as over 1. So we can simply solve for x if we do cross multiply. All right, just for the sake of time, I'm going to multiply everything at once, guys. Negative 5 times x, negative 5x, negative 5 times this, negative 3, that would be positive 15. 1 times negative 2, negative 2. So minus 5x is equal to what? If we get rid of the 15, subtract that, that was going to be negative what? 17. Minus 2 minus 15, that's minus what? 17. Dividing by negative 5 both sides, we are going to have the value of x, which is what? 17 over 5. All right, so 17 over 5, that's something like 3,4. So therefore, our x-intercept will be x 17 over 5. Remember, the y value is what? Is a 0 there. Okay, so that is what you are going to have on that condition. Then the y-intercept, can be calculated where x is equal to 0, y is equal to what? We have y is equal to, we just substitute minus 2 over our x is what? Is 0 this time. All right, so that was it. We're going to have the value of y. All right, 2 over 3 plus 5. All right, so that's 2 over 3 plus 5 there. Or you can just use your calculator at once. 17 over 3. So you're going to have 17 over 3. That's our y-intercept. X is 0. Y is what? 17 over 3 as a point xy. So that is it. With this information, I mean, with the graph that we had, you can just, I mean, with that given f of x, you can determine your x and y intercepts. Then sketch the graph of what? Of f. You must sketch the graph of f. Clearly show all the intercepts with axes as well as the asymptotes. So remember here when we're calculating the x and y value from those axes of symmetry, we are calculating what? The value, we're determining the equations of the asymptotes. We're actually talking about what? Our asymptotes here to say x is 3, y is 5. So let's start with that part of our asymptotes. All right, unfortunately we were not given something to use to all right, so I'm just gonna just have my own presentation here. So let's start with our asymptotes. All right, we're starting with these asymptotes. Right, then we're gonna talk about the shape as well. Okay, let's just have something like this. our y-axis and our x-axis. So in this case, they did not give us the space for us to sketch the graph. We're just gonna do something for our own. That's I just hope you understand me. The graph is more positive, more positive. If you check the asymptote y is equal to 5, that's more positive. The graph is more positive. So let me take this one down. Our graph is more positive. All right. So that's it. That's 0. 1. We need 5. Up to 5. 1, 2, 3, 4, 5, 6, 7, 8, and so on. 1, 2, 3, 4, 5, 6, and so on. -1, -2, 3, 4, -5. Okay, but we do not have more negative values. So on the negative here, there is no need. Our graph is more positive. Okay, so like I said, starting with the asymptotes, x is equal to what? X is equal to 3 as part of your asymptotes. X is equal to 3. So we are going to draw our graph. X is equal to 3. That's at the point. All right, this is our x and our y there. So at x here, draw the line of what? X is equal to 3. So we have this one as what? As an asymptote. X is equal to 3. Another one, y is equal to what? 5. Straight at the y-axis at point y there. At point 5, draw the line that is y is equal to what? Y is equal to positive 5. All right, something like this. So we're going to have these ones as our asymptotes. Y is equal to what? 5. Then what about the shape? As we have got our asymptotes, then we consider the shape of the graph to say A is negative. So if we are given asymptotes like this, we're going to have this one in the second and this one in the fourth quadrant of the asymptotes. So this is the graph, how it was going to look like in terms of the shape. So meaning to say, we are going to have something like this. We're going to have something like this. All right. So thus on this side, as we can see, there's a need for the what? Y-intercept. This side, there's a need for the x-intercept. That is why we have them. So let's put that. What is our x-intercept? Our x-intercept, 17 over 5, which is 17 over 5. That is something like 3,4. This is 3,4. So x being 3,4, let's just say somewhere here. So that's our shape. Remember the shape said something like this. So that's 17 over 5 there on this part. And the y-intercept is going to affect the other side of our graph, 17 over 3, which is something like 5,67. 5,67. So that's 5,67. Somewhere, let's just say something like this. So bounded to the asymptotes. Remember, we cannot cross the asymptotes. So we are bounded or we are limited to the what? To that asymptote. The graph cannot pass these asymptotes. So that's here at 17 over 3. That's 17 over what? Over 3, which is 5,67. All right. So that was going to be our sketch. So we have got the graph of what? The graph of f. This was the graph of what? F of x. So that's our f of x in that case. So this is the most important thing, asymptotes, then x-intercept, y-intercept, the shape of the graph. You are done. All right. So question 5, that was it. Moving on to question 6, which is part of our trig, the trigonometry. 6.1, if sine of 32 is equal to p, determine without using without using calculator here, the following in terms of what? In terms of p. All right. First of all, you're gonna just need a sketch. This is an acute angle. So in our sketch, that's gonna be 32 degrees. All right, so you're gonna have our angle of 32 degrees. All right, sine from the SOHCAHTOA concept. SOHCAHTOA, that is opposite over hypotenuse. So this is sine of 32 degrees being p over 1, opposite. P hypotenuse is 1. So you're going to calculate the third side, which represent x, and that was going to be 1 minus p squared under the square root, all right? R squared is equal to x squared plus y squared. So 1 squared is equal to x squared plus our y represented by p squared. So that's 1 minus p squared equal to x squared. Introducing the square root, that's our x is. There's an acute angle, guys, so that's going to be positive. We deal with positive values. So that was it to obtain the value of x, and that is going to help us to determine the sine of 212. Also determine the third angle. This is a right angle, remember? So 90 minus 32, that was going to give us 58 degrees. Okay, so this is it. 6.11. Let's see what we are given. That was 6.11, the sine of 212 degrees. All right, so 212 is not an acute angle. It is actually to be reduced. Can we work with reduction concept? Can we reduce this from the... We test, guys, we test. So 212 lies in the what? In the third quadrant. So this is the quadrant of 180 degrees plus theta. All right, so if it was going to be written as 180 degrees, it was going to be sine 180 degrees plus what to get 212. So it's simply 212 minus what? Minus 180. That was going to be 32. And we have got 32. So it means it is good for us to use that. We test, guys, all right? So that is it. We are going to use this part, all right, guys? You see this pair now. It just misbehaves when you want to explain something that is important. I don't know. I don't know. Why is this? Why is that so? So using the cast concept and this being written as the sine of 180 degrees plus theta, our theta being what? 32 degrees. It is going to give us a negative. Remember, this is the quadrant for tan. Sine there is what? Is a negative. So it was going to be negative sine theta. Our theta being what? 32 degrees, which we are already having there. Sine 32 is what? Is p. So our answer was going to be minus p. All right, so that was it. This part we just needed to substitute the p, in place of what? Sine 32. All right, let's consider another question. Tan of minus 32. That's a negative angle that we are referring to as a negative angle in the fourth quadrant minus theta. This is the quadrant for cos. So tan is what? Is a negative there. So the tan of minus 32 degrees is the same as minus tan of what? Tan of theta, which is tan minus 32. So do we have 32? Yes, it is part of our diagram. So you can use the ratio of a tan opposite over what? Adjacent. So according to tan, the opposite is what? Is p. Adjacent is, so that's negative opposite over adjacent, the square root of 1 minus p squared, just like that. The square root of 1 minus p squared. So that's it. We are done. The cos of negative 482. 482 is more than 360. Remember, for angles greater than 360, we add 360 or we subtract 360 until we get an angle that is less than 360. Since it is a negative angle, you're going to add 360. Add 360, add until you get a positive. Because the moment you subtract, it will be more negative. If you are given a positive angle, let's say 720, you subtract 360, subtract, because you have a positive. From a negative, you add. So if we're going to add minus 482 plus 360, it was going to give us minus 22. Minus 122, I mean. So that is an angle that is in within the minus, I mean, in between minus 360 to what? To 360 degrees. In between that, as long it can be a negative, as long it is in within that interval, it's okay. So meaning to say this was going to give us cos of what? Negative 122. It is in within our interval. So remember the cos of a negative value, guys, cos when it is a negative like that. All right. So it changes to a positive when it is a negative. All right. But in our case, we must consider to say where this it is it a positive or a negative? That one you can consider according to the angles that you are given. In our case, to get 122, 122, it is supposed to be, let's see the reduction. If it can work, 180, 180 minus what? 180 minus 122. So this is 58. So reduction can work, but let's make cos be a positive. Remember, cos of a negative is cos of a positive. It just changes to a positive. This one is not affected. All right. So this is what we're going to have. But remember, I said cos 22. 122 can be taken from what? 180 plus 58. So this is cos of 180 minus 58, I mean. 180 minus 58. So that's cos of 180 minus 58. Which quadrant do we have 180 minus theta? The second quadrant, this is 180 minus theta as a positive angle. And that's the quadrant of a sine. Cos there is what? Negative. So it was going to be negative cos of what? Negative cos of what? 58 degrees. And thus 58 degrees is there on our diagram. That is going to give us what? Minus the value for cos adjacent over what? Hypotenuse, adjacent over hypotenuse. According to 58 degrees, the adjacent side is what? Is P. That's our adjacent. Hypotenuse is 1. So it's P over what? P over 1. So we're going to have minus P over 1, which is simply minus P. So that's minus P, just like that, all right? So to confirm this, cos of, sine of 32, it's P, meaning to say sine of 32 is a positive value. It's an acute angle. Remember, it's positive. But cos of minus this angle, cos of minus 482 must give us a negative answer. And that is exactly what we have. We have got a negative answer at the end because of that minus P that we are seeing. It tells us that whatever value that you're going to have, it will be multiplied by a negative. So that is going to be negative P, which is correct. All right, that is it. Prove that the left-hand side is equal to the right-hand side. All right, so let's take the left-hand side. From our left-hand side, we have got the cos squared of 90 degrees plus y times the sine of 180 degrees minus y minus the sine of 360 degrees minus y, all right, times the cos squared of y, like that. Everything over what? The cos of 360 degrees minus y. So it must give us a tan. Okay, no problem. Remember, guys, I talked about these reductions, cofunctions, and so on. So the first one, 90 degrees plus y, that's a cofunction. Remember, cos of 90 degrees plus x. In the second quadrant, cos is a negative. So that is going to give us negative sign. The sign has to be multiplied with a negative. So it was going to give us a negative sine x, which is negative sine y in that case. But remember, it is being what? It is being squared. So we are going to square it, all right, times the sine of 180 degrees minus y, which is as a positive angle. That's in the second quadrant. Remember, if this is x, This is 180 degrees minus x, 180 degrees plus x, 360 degrees minus x as positive angles. So that's in the second quadrant, and that is the quadrant for what? For a sine from our cast. So sine will be positive there. Sine of y. All right. So these two be multiplied together. We subtract sine 360 minus y. 360 minus, that's the fourth quadrant, and that's for cos. So sine there is what? Is a negative. So that's negative sine of y times cos squared y. There's nothing that we can do, guys, on this cos squared. It's already in the simplest form. Cos 360 minus y. 360 minus, that's the fourth quadrant as a positive angle. And cos is what? Is positive there as a ratio, as a reduced value. It is positive. So that's over cos of what? Cos of y. All right. Remember, they say the answer must give us a tan. Looking into the numerator, minus sign when squared, negative squared gives us a positive. So it's going to be positive sine squared. All right. You see what I was saying? I have to wait. So this board is teaching me patience, guys. Today you must be patient. Don't rush. All right. No problem. Sine squared of y times the sine of y minus the sine, minus minus, that's a plus. So it's plus the sine of y times cos squared of y. Everything over the cos of y. All right, there's something common in the numerator which we can actually consider. In this case, we have got the sine of y. The sine of y. Common. We can factor it out. Remember, this is a single term. A single term. So we can consider factorization as these two terms are separated with this plus. So that's the sine of y. We can factor it out. Factorize, we are going to remain with the sine squared of y plus, here we are going to remain with the cos squared of y. Everything over the cos of what? Of y. Remember our Pythagorean identity. This one gives us what? A 1. So meaning to say we are simply going to multiply the sine of x times what? The sine of y times 1 over the cos of y. So that's simply sine y over cos y, which is what? Which is the tan. So that's exactly what we're given on the right hand side. They said prove that we must get a tan at the end, and that is what we are having. So as we can see, guys, it's just repetition of questions. We've done questions similar to this one. So prepare, revise more questions. This is the final stage of your high school, guys. So prepare for it. Be in ginger. Be in the spirit for it. Because it's your first time you're writing this. Be in a ginger to say you are ready for mathematics grade 12. The one that everyone will be talking about that is difficult. You must be in a condition that you are ready. Only by revision, more revision. Do as many activities, more question papers. You won't go wrong. This is maths. Pure mathematics. You chose pure mathematics. You must know what you chose. It needs revision as well as much. All right, 6.3. Given that the cos of x, sine of x, the square root of 3, sine x are the first three terms of a geometric pattern. All right, so these are the three terms given. Cos of x, there is a sine of x, and there is 3, the square root of 3 sine x. They form a geometric pattern. Determine on 6.31 the value of x. If x is to be taken in within this interval from 0 to 90 degrees, guys, that's in the first quadrant, remember. So there's no need for you to use even general solutions, because that's from 0 to 90. That's where you find what? The reference angle. So it's part of your reference angle. There's no need for general solutions. Just solve. So how can we solve for x now? They told us it's a geometric. Remember what I told you guys? In a geometric, common, or constant ratio concept can be used. So we can use that to say that the constant ratio is supposed to be equal throughout. T2 over what? Over T1. From our R being T2 over T1 equal to T3 over T2. So you can use sine of x, T2 over T1 cos of x must be equal to T3, the square root of 3 sine x over T2, which is the sine of x. All right. Are we seeing what is happening? On the right hand side, sine x cancels. And on the left hand side, sine over cos is a tan. So that's tan tan x is equal to the square root of 3. Like I said, from 0 to 90, there is no need of you finding any reference angle. The value of x from arctan, what you're given there is your answer. All right, so that's it. So our x was going to be arctan square root of 3, arctan shift tan, arctan square root of what? Of 3. So that was going to give us 60 degrees. So x is equal to 60 degrees from 0 to 90. That is the only solution that you're going to have. Hence, calculate the sum of the first 10 terms, the first 10 of a geometric. So we can determine that 6.32, remember the sum. All right, let me just have it here. 6.32, the sum under a geometric. We can use two formulas actually, but as you have got the one in your formula sheet, I'm just going to use that one so that we just maintain, guys, what you're already given already. Because most of you be working with the formula sheet, you'll be putting the formula sheet like it is the one that is answering exams, guys. Formula sheet do not answer exams. You are the one who answers exams. Anyways, for that, let us put in our values. Our A is the first term. Remember, here, guys, when we were finding, this is our R there. R there. So sine x over cos x, which is this one, it is the same here. It was what? Square root of 3. So meaning to say we've got our R as what? Square root of 3. We have it. R is there as what? The square root of 3. The common or constant ratio is the square root of 3. Or you can just find the terms. You find T1, T2, then you divide. You're going to find that square root of 3. All right. Our first term is A. A is equal to T1, which is cos of x. But we have got our x as what? 60 degrees. We can substitute that x. So that was going to be cos 60 degrees, which is 1 over 2. For the number of terms, which are 10 terms, we can determine the sum. All right, so that was it, guys. Let us determine our sum. So the sum of the first 10 terms is equal to what? A, that is 1 over 2, into our R there, which is what? The square root of 3. Let me just do this way. The square root of what? The square root of 3 raised to the power of what? Of 10, which is our n, minus 1. And this is over what? Our R there, square root of 3. So the square root of 3 minus 1. So that was going to give us the sum of the first 10 terms. Use the calculator at once. It can simplify all this. Evaluate 1 over 2. All right, 1 over 2. Then there, open the bracket. Open another one for the square root of what? For the square root of 3. Close that bracket. Raise it to the power of what? Of 10. Okay, then subtract 1 there. Over what? The square root of what? Of 3. Then move aside, subtract a 1 like this. That was going to give us 165,29. The 9 is going to change 8 into a 9 to what? To 2 decimal places. Remember our instruction. So that's 165,29 to 2 decimal places. All right, so that was 6.32 from what we are given. All right, so just like that, guys, you see now you're back to the sequence, the geometric pattern from Trig. Revise, guys. You see, they form those 6.4, determine the general solution to this, all right, for 7 marks. All right, let's see what we are given. We need the general solution of 6 sine squared of x minus 7 cos of x minus 5, that's equal to 0. All right, solving for x, guys, or for us to determine our x values, we must have a single trig. Cos of x is equal to a, the sine of x is equal to a, or the tan of x is equal to a. Are we having that? We do not have that. So you need to figure out how to have a single trig being equal to a constant. All right, there is a sine, a cos. Which one is easier to change to another form? A sine to be changed to a cos, a sine squared to be changed to a cos, or a cos of x changed to a sine. You can see that this is easier from our Pythagorean identity, because we have got cos squared also and what? Sine squared combined together. Cos squared plus sine squared of x is supposed to give us what? It's supposed to give us a 1. As a combined identity, we can make sine squared the subject of what? The subject of the formula from there, all right? All right, all right. This body plays with me, guys, you see? Anyways, sine squared of x is equal to, take this to the other side, that was going to be 1 minus cos squared of x. This represents sine squared. So in place of the sine squared, we are going to substitute with its equivalent, 1 minus what? Cos squared of x. All right, this is already in terms of a cos, so there's no need for you to change it. It's gonna as it is. So that's a quadratic that we have formed under a cos. So let's solve. 6 expands the bracket. 6 times negative cos squared of x, negative 7 cos x, negative 5 is equal to 0. So this is negative what? 6 cos squared of x. All right, it's now like I'm writing Japanese or Chinese. All right, cos squared of x minus 7 cos of x, that's 6 and 5 there. So if we collect those together, 6 minus 5 was going to give us what? A 1. So that's positive 1. Okay, that's a positive 1 that we are going to have. Okay, no problem. So that means we're going to have positive 1 is equal to 0. So with this, we can solve for x. We can have our quadratic formula, of which we can also avoid this negative, guys. Just divide by what? Negative 1, negative 1, negative 1, negative 1. So that is going to give us a positive. There's 6 cos squared of x, negative, negative, 7 cos of x, positive, negative, negative 1. That's equal to 0. Of which you can just use the quadratic formula here without even this division. But that is just formality for you guys to work with the positive, so that it will be easier for you to not or to use your formula without any challenges. If x is equal to, here we are dealing with the cos of x, cos of x. So therefore, we're going to write our formula as cos of x is equal to minus b plus or minus the square root of b squared minus 4ac, everything over what? Over 2a. Substituting into this formula, our a, b, and c, we have cos x, single trig, a single trig. This is what we want. Cos, sine, or tan of a single trig. So the moment we are solving here, we are obtaining a single trig, all right? So that's negative our b, 7, plus or minus the square root of b squared, that's 7 squared, minus 4 times a, which is 6. Our c, that's negative 1, everything over 2 times 6. So that was going to give us what? 2 possible values for the cos of x. All right, of which you can simplify what is under the square root if you want, or you can just simplify these values at once. What is under the square root was going to give us 73, like minus 7 plus or minus square root of 73 over 12. All right, which we can simplify. Let's see. negative 7 plus the square root of 73, everything over 12. This is going to give us 0, 0.2, 0, 0.12, and so on. 0, 0.12, and so on, and so on, and so on. All right. 0, 0.12, and so on, and so on. Let me, I can even store this value in case I'm going to need it. So to store it, shift store, then I can press A. So the answer is in what? In A. All right. As for the second one, the cos of what? Of x was going to give us, if we simplify that, gain negative 7 minus the square root of what? 73, everything over 12. This was going to give us a negative 1,29 and so on. All right, negative 1,29 and so on. There is no solution. Remember, A, if we say cos of x is equal to A is supposed to be greater than negative 1 but less than 1. So this one is way out of our interval. That means there is no solution on this one. Even if you're trying to find the reference angle, the moment you say arc cos, all right, remember we use it as a positive. So you're going to take it as a positive like this. Then you're going to have arc cos of what? Of our answer. As you can see, guys, met error. There is no solution there. So our solutions are going to be obtained from the first one, the cos of x, which is 0, 0.2, and so on. Remember here, there are so many values that we are to use. So this is it. For us to have the general solution, we must need to calculate the reference angle, which is arc cos of what? 0, 0.12, and so on. So this is the value on your calculator. Remember, we stored this value in A, recall A like this. Recall, where am I pressing shift? Recall, this one, recall A. This is our value here. So if we want this value, just gonna recall it. So that's for us to have what? The reference angle, shift cos, that is arc cos, recall A. Remember our answer is in A. So that was gonna give us 82,61 to 2 decimal places. Also, you can fix your calculator to 2 decimal places. 82,61. So that's 82,61 degrees as our reference angle. What about the solutions? Cos is what? A positive. The value that we are given here is what? Is a positive. So if it is a positive, we must consider the quadrant where cos is what? Positive. That's it. So from our cast, cos is positive first and what? Third. So here we're just going to have our reference angle. Here it will be 360 minus the reference angle. All right. So meaning to say, therefore, x is equal to what? This is cos of x, remember. So x is equal to, in the first quadrant, you just take your reference angle as it is. So it was supposed to be reference angle plus k times what? 360 degrees. This is what we are going to have. So in our case, the reference angle is there, guys, 82,61 plus k times what? 360 degrees. And this k must be what? An integer value. All right. Then, so that was the first solution which we obtained in the first quadrant, or in the in the fourth quadrant. There, our x was going to be given as 360 degrees minus the reference angle. 360 degrees minus our reference angle is what? 82,61 plus k times 360. Or some they use plus or minus. You can use plus or minus reference angle plus k times what? K times 360. Some they just use the reference angle as plus or minus for a cos when it is positive, or you can just use this one. It's one and the same. So that was going to give us 360 minus 82,61, which is 277,39 degrees, plus k times what? K times 360 degrees. So this is the conditions that you're going to have as your general solution, this one and this one. Two general solutions that you are going to have from what we are given. And those are the ones that we are going to use now to determine the exact values for that given solution that you'll be actually working with. So you now determine exact values from there. So all you need is to work out as many questions, do as many questions as you can as an individual. Try to work out as many questions. So that was it, guys, for 100 marks. All right, Northern Cap. Okay, it's a lot. It's a lot that we had, but it is good for revision as a student. This is good in terms of revision. You can cater for everything that you have done in your term 1 and also your grade 11 mathematics, as we saw that they also gave us the part of what of our question 1. So it was a good thing actually to have that in an exam, because you not forget to say algebra is part of your grade 12. Some of you remember this when you're about to write your final exams, or they in June. That's where now you start to recap those things of which it will be too late. Recap now. By now you must know that. All right, so that is it, guys. Till we meet again.